do we have our notes out? We are ready to add to our notes. All right, we're only going to add 2 examples. How many examples did we do in the video? We did 3. Okay, so we are on example 4. Okay. Example 4. I am almost done grading the quizzes, but not quite. I got to where I felt like I was going to go to sleep, and I closed my eyes. The end. Okay. All right, so here's the example. -3 times e to the 2x minus 5.4 equals 11.6. Okay, so whenever we are solving for a variable, what do we always do first? Yeah, we see what we can add or subtract to the other side to start getting the variable alone. Is there anything that we could add or subtract to the other side? There is not. Sorry, the 11.6 should be negative. Sorry, go ahead and put a little negative sign there. I missed it. Okay. So for this particular problem, there's nothing we could add or subtract to the other side to start getting the x alone, so we just can't do that step. So the next step is we would look for what? Could we multiply or divide anything over? And we can divide something over. What can we divide over? The -3. So we get e to the 2x minus 5.4 equals...
According to my calculator, 58/15.
58/15? So you typed in 11.6/3 and you just got a better fraction, basically. Yeah. So we can leave it as 11.6/3, or we can do 58/15. Either one of those is fine. 11.8/3, if you do it as a decimal, is probably not a good decimal, and we don't want to round at this point in the problem. So we're not going to do a decimal yet, because rounding as the first step in the problem is not a good idea. Okay. So now we're on to step 3, which is, so this has to do with exponents. So can you get rid of an exponent? Can you add in an exponent? What do you need to do that has to do with an exponent for the problem? So we are trying to get rid of the base so we can break into the exponent. That's why we're doing this for step 3. So how do we get rid of the base? Yeah, we're going to do natural log. So we're going to log base e each side. Yep. And log base e is actually an ln. So we're going to say 2x minus 5.4 is log base e of 11.6/3, which is the same thing as ln of 11.6/3. And so what just happened is we had this exponent that technically was in parentheses. It was grouped. It was a group. So we just actually did step 3 and step 4 all together. And so now we're back at the beginning where we are trying to get the variable alone by seeing if there's something we could add or subtract to the other side. So what could we do? The 5.4. Okay. So 2x equals ln of 11.6/3. The 5.4 happened after the ln of 11.6/3, which is why it gets added to the end and it's not inside. Happened after. Okay. And then what do we need to do next? Divide by 2. The entire thing. Divide by 2. So x equals that whole mess. So ln 11.6 divided by 3 plus 5.4 over 2. So I'm just typing in the whole thing exactly the way it looks on my paper. So I'm going to say that this right here is actually the answer. This is one answer. This is called the exact answer. And then the approximate answer is the decimal I'm about to get. And what'd you guys get for the decimal answer? Anybody? Yep, 3.376. Was everyone able to get that? Yeah? Were we able to get that? Okay. I was looking down, so I didn't hear the nods. Yes. Yes, we got it. Marvelous. Okay. All right, one more example, and then I'm going to let you guys work on your coloring sheet for today. Oh my gosh, you guys. Okay, I have a coloring book. It's all cats. It's cat derrieres. Ooh. And Dr. Davis said I was not allowed. Dr. Davis said no. Well,
Because that would be so funny.
it was cat derrieres with puns. It was cat derrieres with sayings. And I was like, Dr. Davis, this is very funny. And she said, it is very not professional. And I was like, is it though? And she said, yes. It is very not professional. And she said, do you know what kind of parent emails I would get if you used that? And I said, oh no, I don't think you'd get any. And she said, really? Have you looked at this one? It's over there. It's by the plant. And I was like, but come on, it'd be so funny. And then I started flipping through, and she said, Katie, no. And then I knew it was serious. Here's how I know she was serious. Every time I've asked her a question since then, she always says, no cat butts. She's been no cat butts. She's been saying that the last 5 times I needed to ask her a question ever since I asked her the first time. And I'm like, no, that's not even what I was asking. So I know it's a hard pass. So I would have to get a different one. It's a very funny coloring book, though.
Pixelation thing over the entire image.
Books were traumatized.
Yeah, I would.
Like a bunch of,
We have to draw a bunch
it's just a
of
bunch of squares then.
or color a bunch of anatomy parts for anatomy class. And I'm betting he didn't ask to use that.
I mean, something got improved in the psych curriculum.
Oh, we're not coloring anything.
Yeah, we're not coloring that. But that was a proof of a cat butts, no.
That's wild.
And we turned it all in for
Educational.
Mine could have been educational.
Yeah.
I don't know.
It would have been like, what does this pun mean?
Let's think about this. Take a deeper dive.
All right. Okay, example 5. We're going to do -1/3 times 5 to the 11 minus 6p plus 4 equals 1. Lots of numbers.
Or did you Google it?
Definitely.
All right. So, step 1. Is there something we could add or subtract? 4. Okay. And then what should we do? Multiply by -3. So the -1/3 in the front, you can multiply it over or divide it over, depending on how you handle it. And I agree, I think it'd be easier to multiply. So we can multiply by -3, and then multiply by -3. And then for the next step, do we divide by 5? Okay, so the next step is our exponential step. So we are saying somehow we are introducing an exponent, or we are getting rid of an exponent, or we are doing something to bust into an exponent. And that's what we're doing here. We need to get rid of the base so we can get to the exponent, which means we have to log base 5. Log base 5. Okay. And the exponent 11 minus 6p was a group, so we did step 3 and 4 together. We got inside our grouping symbols, which was our parentheses, even though we didn't see them. And so now we're back at the beginning. So to get the p alone, is there something we could add or subtract to the other side? Subtract 11. So are we going to get log base 5 of -2? No. Why not? Yeah, the 9 is locked in. Yeah, the log happened to the 9. It did not happen to the 11. It happened already. So log base 5 of 9 is locked in. Minus 11 happened after that. Okay. All right, then what do we do? Divide by -6. Okay. Now, can the -6 simplify with the 9 or simplify with the -11? No, it cannot. That stuff is locked in. Okay. So our exact answer is going to be log base 5 of 9 minus 11 over -6. Did the what? Oh, it did. It did break. So there's our approximate answer. Now, if a mathematician-y person did not want the negative on the bottom, they could move the negative to the top, and they could make it negative log base 5 of 9. See how I'm just moving it to the front? Plus 11. That's the only way they could fix the problem, to take the negative off the bottom, which is a strategy we've seen multiple times. So if they chose to do that, that's how they would choose to do it. That would be fine. So, huh? Yeah, if you did that automatically, that's fine. If you didn't do it, that's fine. Because for this today, we're going to be doing decimal answers. Yeah. All right, so let's go ahead and type it in. We've got fraction, math up, log base 5 of 9 minus 11 over -6, which gives us 1.606. Okay, were we able to get that? Okay. All right. Looks good. Everyone feels comfortable. Now, for the assignment today, I have a mixture of problems. So if you look at the assignment, let me zoom out, you can see problems like, oh, look at number 2. Those have the same base. I would not log both sides. That one's ready to go. Just cancel out the bases. That one's ready to go. If I look at number 1, 64 and 16, does that seem like a problem from today? No. What do you notice about 64 and 16? Yeah. So some of these problems are actually from our previous assignment. From what day was that? Thursday? So it's kind of tying together, we've actually learned two methods for solving these equations. One of the methods was if you can change the base so that they're the same, do that. And then the other method is if you can't change the base so that they're the same, take the log. Yeah. So some of these problems can be solved two different ways. Okay. Like for instance, we could do the log method on this problem if we wanted to. We just don't have to. Okay. To take logs. On a problem like this, it wouldn't be. It gets really convoluted on a problem like this. Because you can see your bases are different. So you'd end up taking a log like this. You could do a log base 16 on the right side, but if you did a log base 16 on the left side, it wouldn't cancel it out. Yeah. So when you work on this, just keep that in mind that some of the problems are actually our old method, not the one that we learned today. Okay, so be on the lookout for that. So it will be helpful for today to have your little sheet out. If you lost it, I do have some more that you can use. So this is what we're working on today. You guys have done it before. We do have the coloring page, which is optional if you choose to do it. And then the answers are right here. I do not think there are any typos, but you know me. There's always one. So let me know if you guys find one, if there's an answer that doesn't seem to be right, and I will shout it out if we end up finding one. Okay? So this is what we're working on this period. Tonight's notes for homework, there is a sheet for it. So I will come around and hand you guys the sheet for tonight's homework. But this is all we're doing this period. Okay? Sound good? Alrighty, go ahead and get started.